Hello, students. Your teacher here, Mr. Sirasinski. Sorry I had to be out today, but I am planning on working through some of these examples in the review to help you be better prepared for your test. I will tell you that the test is going to be very similar to what's on the review, but just a little shorter. So here we go. Topic 1.1, the real number system. List all sets to which each number belongs. I stands for irrational, Q is rational, Z is an integer, W is a whole number, and N is a natural number. So for our first example, we have negative 14 divided by 2, and negative 14 divided by 2 is negative 7. All right, now I actually have the number. Negative 7 is rational and an integer. It's not a whole number because it's negative. Number 2, the square root of 64 is 8. 8 is rational. It's an integer. It's a whole number, and it's a natural number. Number 3, 0. 0 is rational, an integer, and a whole number, but not a natural number. Remember, babies don't know 0. And pi is irrational. Leave the other 4 for you. Properties are for you. Let's look at the closure property. For the closure property, we're trying to determine if an operation always produces a number in a certain set. If it always produces a number in a certain set, then it's closed. If it doesn't, then you need to provide a counterexample showing why it doesn't work. So, A, integers are closed under multiplication. Well, I know integers are all whole numbers and their opposites. So let's see. I think it's true, so I'm going to put true, but also I'm going to just try some examples. So integers, let's say 3 times negative 3. That's negative 9. Negative 9 is an integer. All right, how about negative and a negative. Negative 2 times negative 3. Well, that's positive 6. Positive 6 is an integer. So, yeah, that's true. I'll let you guys try B. Topic 1.4 and 1.5, order of operations. Remember, PEMDAS. Parentheses, exponents, multiplication, division, addition, subtraction. And the reason I put the slashes there is because I want you to remember that these two are left to right. So you don't necessarily do multiplication before division or addition before subtraction. You just go left to right, just the same way you read. If division comes first, that's what you do first. If subtraction comes first, that's what you do first. All right, so all 3 of these are yours. I'm going to take one of the substitution examples. So let's look at number 21. Let's just take the hardest one off y'all's plate. Important thing to remember is that when you substitute, you always use parentheses around the value that you're substituting. So I have negative 2 squared minus 2 times negative 3 times 1. And same for these, order of operations, right? Okay, PEMDAS. Exponents first. Negative 2 squared is positive 4. Always remember that when you're squaring something negative in your calculator, you have to put parentheses around it. If you don't, and you put it in your calculator, it'll tell you it's negative 4, and we know that's not right. So don't make that silly mistake. Put it in parentheses. All right, so we got positive 4. Bring everything else down. And then I'm going to multiply these straight across. 2 times negative 3, negative 6. Negative 6 times 1, negative 6. So I have 4 minus negative 6. Change subtraction to addition. Change the sign of the second number. The answer is 10. All right, let's keep going. On your calculator, really quick, when you're raising something to the third power, you have to use the little caret button. I think it's above division, and then hit 3. Okay. Topic 1.8, distributive property, combining like terms. So if you see parentheses, you're doing the distributive property. And you can only combine terms when they have the same variable with the same exponent. Okay, we cannot combine variable terms and constant terms, and that's important. All right, so let's jump ahead to, I'll do 23 and I'll do 24. All right, 23, 7x, negative 3x are like terms. Negative 4y minus 8y are like terms, and negative 8 plus 12. And when I combine these, remember you take the sign. So 7x plus negative 3x, or just 7 minus 3 is 4x. Mark it out. Notice I started with x and not y. Alphabetical order. Negative 4y minus 8y. They're both negative. Add them and keep the sign. Negative 12y. And negative 8 plus 12, or 12 minus 8, is 4. And that's my answer. Cannot simplify it anymore. None of those are like terms, and there's no more parentheses, so that is how I know that it is fully simplified. Number 24, we see parentheses, so that means I need to do the distributive property. Distribute means to multiply, and so I get 18, and I'm going to treat that like a negative 2. And so when I multiply, this is going to be negative 8x minus 14, and then bring down the 5x. Let's combine like terms now. So we've got 18 and negative 14 and negative 8x and positive 5x, and start with the variable term. So negative 8 plus 5 is negative 3x, and 18 minus 14 is 4. All right. Topic 1.9, translating. Biggest thing I want to remind you about here, a couple things actually, is means equals. And watch out for less than and subtracted from. Those are backwards word phrases or turnaround phrases. And so you don't write them the way you read them, you write them the opposite. Okay, so I see, let's see, oh, right here is one. Okay, so watch out for that. Gonna see one like that on your test. So make sure you are recognizing that and know what to do. Same, they're equivalent. Not sure what button I hit there, but okay, so those are yours. These equations we've been working on, and so I don't want to do them. Proportions I will do because I don't think you guys all remember how to do those very well. So I'll take one of these. I'll take 37. So proportions, biggest thing, and these are easy to recognize, is that you have to remember to cross multiply first. Okay. So I have 3 times p plus 7. Remember, if you're multiplying one term by two terms, then it goes inside parentheses. Okay. So that was cross multiply. Now, since we have parentheses, we're going to distribute. Bring my steps over here. I don't want to crowd that other problem too much. So I get 3p plus 21 equals 6p plus 12. Now I need to get the variable on one side, and I know some of y'all like to keep the coefficient positive, but I'm old school. I like to just move it to the left, So I'm going to take 6p, and I'm going to move that left, and I get negative 3p. Bring everything else down, so plus 21 equals 12. That was ESPO. Okay. All right, now we have to get rid of the 21 and the negative 3. Subtract 21. Negative 3p equals negative 9. Divide by negative 3. P equals positive 3. Okay, Literal equations. The only one I'm going to do is 41. So we're solving for W. That means I need to get rid of the 2 and the L. Since 2 is being multiplied by this parentheses, then instead of distributing, I can go ahead and divide 2. So I get P divided by 2 equals L plus W. And I can drop the parentheses now that there's nothing outside of it. And since we're solving for W, we got to get rid of L. Well, subtract it. W equals P divided by 2 minus L. Now, some of you like to do this after you distribute, so I'm going to show you both ways. If you distributed first, you'd get 2L plus 2W. And so we got to subtract 2L. P minus 2L equals 2W, and then divide by 2. Now, these things are the example. I just changed the slide. Okay, so we've got P minus 2L divided by 2. Now, if I were to simplify this, because they look different, right? The answers look different. Well, this would be like P divided by 2 minus 2L divided by 2 equals W. And those two will cancel out. So I'll get P divided by 2 minus L equals W. Now they look familiar, right? Okay. And last page. All right, absolute value functions. You guys struggled with this. For some reason, you guys always forget to do the second equation. And I'm not sure why, but I'm going to take one of these. I'll go ahead and take this one. So when you're solving an absolute value function, first, isolate absolute value, all right? And if there's anything outside the absolute value, then we need to move it to the other side before we can start to solve this. So it's going to feel weird, right? Like you're trained to distribute, isolate the variable. These are different, and you need to remember that. So for number 44, isolate the absolute value. That means I need to get rid of 3. So I have 4 times the absolute value of V minus 2 equals 38. And since V is, or 4 is being multiplied by the absolute value, I need to divide. Okay. Now, this is not going to come out very good. This is going to be the absolute value of V minus 2 equals 9.5. How about that? Okay. Now the absolute value is isolated. Set equal to positive, negative on other side. So V minus 2 equals 9.5. V minus 2 equals negative 9.5. And then I just solve each one. Add 2. V equals 11.5. Add 2. V equals negative 7.5. Okay? Absolute value functions always have two solutions. So V equals negative 7.5 and positive 11.5. Okay. Multi-step inequalities. Couple of rules here. Greater than or less than equals an open dot. Greater than or equal to, less than or equal to equals a closed dot. And the inequality symbol always points to the direction that you shade. That's important. So if I have greater than, that's pointing to the right, which means I'm going to shade to the right. If I have less than, that's pointing to the left. So I'm going to shade to the left. Okay? All right. Number 47. I'll do the big one for y'all. Distribute 2x minus 18 minus 3x. Bring down the sign. 5x plus 24. Combine like terms. I'm going to bring everything down. 2 minus 3 is negative 1x. Add 1x to both sides. So this was distribute. Combine like terms. APO. 6x plus 24 is greater than negative 18. Subtract the 24. 6x is greater than negative 42. Divide by 6. And since we're dividing by a positive number, we do not have to flip the inequality sign. X is greater than negative 7. So since it's greater than, I have an open dot at negative 7, and I shade to the right. So all these values to the right are my solutions all the way to infinity. All right. Compound inequalities, one and, one or. Here we go. So or statements always graph away from each other, and statements always graph towards each other. That is something that I think is helpful to remember. And that's it. Okay, let's keep going now. 49. These are just two-step inequalities. Not that hard to solve here. But I think when students go to put it on the graph, they get mixed up. Also remember, if you multiply or divide both sides of the inequality by a negative, gotta flip the sign. All right, so we're adding 1. Negative 2x is less than negative 16, and I'm about to divide by a negative. So I know I have to flip that sign. There we go. Okay, flip it. And in this one, we're going to have to do it 2 times. All right, subtract 1. Negative x is greater than or equal to 3. Divide by negative 1. Can't leave x negative. But when you divide by a negative, again, flip it. All right, so x is greater than 8. X is less than or equal to negative 3. Let's start with this one. Greater than 8. That's an open dot, and it's shaded to the right. Less than or equal to negative 3. That is a closed dot, shaded to the left. And that's it. Notice how the graphs look similar to what I said. Okay, number 51. This is a compound and inequality, and they graph towards each other. And these are actually very unique because we solve them all at once. So now we're trying to isolate the variable in the center of the inequality. So first, I'm going to get rid of the constant, and I'm going to add it on all 3 sides. In the middle, they cancel out. I bring down my signs. Negative 6 plus 10 is positive 4. Negative 24 plus 10 is negative 14. And then divide by 2. 4 divided by 2 is 2. Negative 14 divided by 2 is negative 7. So I've got a closed dot at negative 7, open dot at positive 2, and everything in between is a solution. I am your teacher. This is the way.